everyone, our team has 4 members. My name is Lily, this is Annie, Peter, and Jerry. Stand up this morning if you are eager to learn more about fintech and its interesting findings. The fintech lending landscape encompasses digital platforms that provide lending services, leveraging technology and data analytics. Its significance lies in its transformative impact on traditional lending and alternative credit scoring. The objective of this report is to highlight key insights from the fintech lending process, implications of unconventional data sources, and its pitfalls in credit scoring. Finally, figuring out the variables affecting default rates. Fintech lending firms optimize the loan application process in 3 steps: application for a loan, credit evaluation, and loan review. The procedure begins when the borrower initiates the loan application, then provides personal and financial information. The subsequent procedure entails underwriting and risk assessment, utilizing both conventional and unconventional information to make approval assessments. The process either ends with a rejection or continues with structuring the loan. Interest and principal repayments follow as the loan is paid off. Nowadays, many fintech firms apply alternative data of credit scoring to resolve the challenge of extending credit to consumers who are considered credit invisible by traditional credit systems. Unconventional information could be divided into 2 basic categories: auto financial data and non-financial data. Auto financial information could obtain sales data via e-commerce platforms, bill payments, bank account balances, and assets. Customer spending patterns can provide insight into their credit worthiness, since consistent spending and timely deposits are indicators of financial health. On the other hand, other non-financial sources include public records, digital footprints, carbon footprints, psychological data, personality traits, and relationships. For example, digital footprints can better serve the growing segment of young salaried adults who are active mobile phone users with strong social media presences.
Before conducting analysis to determine which provided data that can help predict default risk, we reviewed this paper to get insight regarding unconventional data. This research paper indicates that digital and carbon footprint, even writing styles, can significantly enhance assessment and reduce default rate. These data can be easier to collect than traditional data, but it also has some limitations like not being researched enough and raise ethical consideration.
With these data in mind, we examined 2 key relationships: income consumption and the impact of environmental spending on default rate. For income consumption, our linear regression analysis revealed a highly significant correlation between annual income and total spending, with an impressive R-square of 0.99. This indicates that change in income strongly influences spending habit, with $1 increase in income correspond to a 60-cent increase in spending. Turning to environmental spending impact, our logistic regression showed a low but positive coefficient, suggesting that higher environmental spending associated with increased default likelihood. However, this finding wasn't statistically significant, indicating a modest predictive power. The model R-square value of 0.009 suggests modest predictability, while the AUC of 0.58 indicates a fair performance in predicting default. We then turn to explore default probability across quartile groups based on environmental spending. Results revealed that applicants in the highest quartile exhibit the highest default rate, suggesting a correlation between lower environmental spending and higher default likelihood. However, it is important to note that this association lacks statistical significance. Overall, while our analysis suggests a relationship between environmental spending and default rate, further investigation is needed to establish a conclusion link.
To predict the default probability based on the provided data, we will use the logistic regression model. There are 3 models, one with almost all the variables included, the second one only includes the top 5 variables that have statistical significance in the first model, and the final model only included the statistical significant variable in the second model. We can see from this that the area under the curve of the model with only 3 variables is around 0.69, which is a good predictive power in information scarce environment, and only a little lower than the model with 17 variables. This can imply that the variable in the model with 3 variables, income, home utility expense, and monthly loan payments, are the key variables in predicting the default risk. This is in accordance with other paper results also as shown here. However, it should be noted that there is a multicollinearity between income and expense, which makes it harder to interpret the impact of each variable on the default rate. Still, we decided to use this variable as they contribute to a higher area under the curve, indicating stronger predictive power. In conclusion, although the predictive power will be lower when removing some variable, focusing only on key variable can help to simplify the model, reduce the energy consumption and time for running the model, and reduce the cost of data collection while still achieving a good default prediction model.
Regarding issuing advanced scoring, there is a potential that significantly more data will be collected that could reveal sensitive information customers do not want to be included in their credit evaluation. Furthermore, the risk of having a lot of variables that exceed research capacity should be considered. The researcher's subjective preconceptions and personal experience may also influence variable selection. Finally, the model's conclusion may contradict original belief or common sense and doubt the validity of the findings. Regarding the unconventional data ethical impacts, the use of unregulated, non-traditional data sources such as browsing history or social media profiles may lead to societal discrimination or systematic disparities. Privacy concerns might arise if customers weren't informed about the consent to have the data used. There is also concern about the responsible use of personal data as the information could be sold to a third party. Furthermore, unconventional data validity is difficult to verify, leading to a trend of data manipulation to boost creditworthiness. Additionally, unconventional data may exacerbate the already difficulty in accessing financial services for people who have limited exposure to digital services and perpetuate poverty cycles of these vulnerable communities. Lastly, there are currently not enough regulations to oversee the use of non-traditional data in credit assessment, meaning misapplication of the data and possibility of inadequate accountability or injustice. In conclusion, we discovered that income has a strong correlation with all expenses, implying that it can be utilized to identify anomalies. On the other hand, there is a weak relationship between environmental spending and default livelihood, so this element should not be considered in default decisions. Our logistic regression analysis also showed that the model with monthly loan payments, income, and home utility bills have the highest predictive power with fewest variables, therefore minimize cost and time involved.
At first, we equally divided 4 research papers to review and analysis. In this project, Lily takes the responsibility of researching the implication and ethical impact of alternative data, pointing out the outlier and solution for the dataset. For Annie, she has done the reflection of unconventional data, basic statistics, and issue in advanced scoring. For Peter, he has done the lending approval process, visualization, and income consumption analysis. And for me, I deal with the environment spending analysis and predictive model.
During our construction of the predictive model, we encountered numerous problems associated with the decision of whether to maintain or eliminate variables, as well as backing up by insight.
We resolve this issue by making one model with all the variables and choose the variables that are statistically significant to make the final confined model.
This report taught us how to build and analyze a projected model, as well as how different variables influence loan approval decisions. Thank you for listening.